And now let's look at one more method that we could use to solve this. Now, I know what you're thinking, do we really need another method? But this last method could be good if you've got something that you actually don't know how to graph. We know how to graph a hyperbola and the line y equals x, and we know how to graph cubic curves. But what if we ended up with something that we weren't sure how to graph? What would we do? This gives us a workaround. Now, the first thing I'm going to do is get everything on one side. So let's start by actually just subtracting x from both sides. Now, part of this method would also be to say, hey, by the way, x can't equal 2. I think that's probably a good idea anytime. Now we can look at this and say, well, can we tidy this up in any way? If we're subtracting numbers and one of them's a fraction, it might be nice to sort of make them have a common denominator. So you can leave out this line if you like and do it in your head, or you can show every single step. I'm going to show it just so that I don't lose anyone. If I make virtually what is x over 1 have a denominator also of x minus 2, then I can do that just by multiplying top and bottom by x minus 2. See what I did there? And that is all less than or equal to 0. Now I can bring the whole thing together and give it one denominator, and on the top I've got 3 minus all of this. Okay, so I've shown you that there so that I don't lose anybody. What I probably might do at this point is actually expand my brackets, but just be really careful because this minus sign here can cause you to make a classic sign error with the negative sign over here. So there's never any disadvantage to going a little bit more slowly and carefully to make sure that you get it right. This is a plus 2x because we've got minus x times negative 2. And now I get this. Now, we're trying to tidy this up. So, I mean, this is factorizable, what's on the top. I don't tend to enjoy factorizing when I've got that negative x squared. So I'm thinking, why don't I just multiply this whole thing by negative 1 and this whole thing by negative 1. And that tells me that instead of minus x squared, I could change it to positive x squared. Instead of positive 2x, I could have minus 2x. And instead of positive 3, I could have minus 3. Now, I've just changed the sign of everything on the top because I've effectively just multiplied that whole thing by negative 1 and multiplied this by negative 1 as well. I don't need to multiply the bottom as well. I'm just multiplying each side. So effectively, I've still got my x minus 2 down there, and 0 multiplied by anything is still 0. Now, I've multiplied by negative 1, so there is an area I could have made a mistake. I almost did. Nearly forgot to flip the sign, but caught myself just in time. Okay, now I can factorize the top. That gives me x plus 1 and x minus 3 all over x minus 2. And that has to be greater than or equal to 0. Now, this looks similar to what we did in the first method, except when you look at that and say, can we graph y equals all of this? It might not be quite so easy because perhaps you're not quite sure what this graph looks like. So what do we do as a workaround? Pretty much by looking at what the boundary points might be, or the points of interest, we can consider where the graph of y equals this would sit above the x-axis, or the line y equals 0. And without actually being able to sketch it, we can still see where it might dip above or below that x-axis. So now I've drawn up what I'd call a table of signs. I've considered what x might be, and I'm interested in what happens when x is negative 1, 2, or 3, because those are the key sort of points that I've got in my function. But I'm even more interested in what happens on either side, either to the left-hand side on the graph of y equals all of this, the left-hand side of x equals 1, between the values of minus 1 and 2, actually at 2, between 2 and 3, at 3, and beyond 3 to the right. So I've put some asterisks here to show that I've already considered that x can't be 2. So when x is 2, 2 minus 2 is going to be 0. Well, that's actually okay, but we've considered that this won't be. So here I've got each of the 3 parts of my function. I can consider separately whether they're going to be positive or negative for different values of x. And then I've got the whole thing once it's combined. Now I know that 2 can't work for this whole thing. So basically that's a no-go zone. So let's consider when x equals negative 1, x plus 1 is 0. And that's going to make the whole thing 0, isn't it? Now, I don't have to fill in every single thing on the chart. I'm trying to sort of take shortcuts. What I really want to know is the sign of all of this. When is it greater than 0 and when is it less? And I've sort of got some ranges here between some key points. So if I can see that this part will be 0 when x is negative 1, and that's going to make this whole thing 0, I don't really care what this and this will be. I mean, sure, -1 minus 3 is going to be -4, but who cares? I'm not really interested. All I want to know is, when is it going to be 0? When is it going to be greater than 0? When is it going to be less than 0? So I've considered that. What about when x is 3? Same thing. This part will be 0. And so then this whole thing will be 0 because I've got the 0 multiplied by some stuff. And no matter what I've multiplied or divided by, if this part's 0, then this whole thing will also be 0. Now we can consider kind of horizontally. If we know what x is, and it could be maybe smaller than -1, between -1 and 2, between 2 and 3, or bigger than 3, what will x plus 1 be? It'll just be 1 bigger, won't it? So, I mean, pick out the things that are easy. 1 bigger than 2 is 3. 1 bigger than 3 is 4. Now, all we really want to know here is it going to be positive or negative? So instead of writing 3 and 4, I'm just going to say it's going to be positive. It's going to be positive. If x is -1, then x plus 1 will be 0. So anything bigger than that, that's going to be positive as well. So I can see it's going to be positive all the way along here. But if x is anything less than -1, then adding 1 to it, it's still going to be negative, isn't it? So I can see that it will be negative for any values of x that are smaller than -1. What about x minus 3? Well, if x is 3 and we subtract 3 from it, it's going to be 0. So if we start with a smaller number for x, these are all going to be negative. That's quite quick and easy to fill out. And if we know that x being 2 will make x minus 2 0, then we can reason that on this side of it, it will be negative. And for bigger numbers of x that we start with, it will be positive. Okay, now we can actually just say, well, what will we get here? If we've got a negative times a negative, that's a positive, divided by a negative, it's going to be negative. Here, if we've got a positive times a negative, that's negative. But when we divide by a negative, it's going to be positive. And if we have a positive times a negative, we'll get a negative. And when we divide by a positive, it will still be negative. What about up here for bigger values? Well, this is going to keep being positive. This one's going to be positive once it's bigger than 0. That's a positive. So a positive times a positive divided by a positive, it's going to be positive. Now, what does this table of signs tell us? Well, we're looking for places where all of this is equal to 0. Well, that happens here and here. Or greater than 0. Well, that happens when it's positive, here or here. So what we want is values of x from -1, and including -1, because that gives us 0, and that's allowed, all the way through to 2, but not including 2. So that gives us this, because I can see that it's 0 or positive from here to here, but not actually at 2. We don't want this section from 2 to 3, but from 3 onwards, yes, it's 0 or positive. So we can get our answer that way. Now, this third method is probably the least effective and the most time consuming of the 3 that I've just shown you. But the reason I'm showing it to you now is because if we have something that we're struggling to graph, then those first 2 methods would fall down. And this method we can use for just about anything. We can investigate the sign of something that's there and see if it is in fact positive or negative. So by getting everything on one side and comparing it to 0, this table of signs can help you solve so many of the harder ones. Now, this idea of making a table of signs to think about the graph of y equals something, even when you're not exactly sure what that graph looks like, is quite handy, okay? And you can see how it will work here. Now, if I was to graph y equals this, I'm pretty sure it's a hyperbola of some kind, but let's just say we didn't know how to graph it. Well, then we could say, what would the points of interest be? Well, points of interest are always the x-intercepts when we're thinking about the sign of the function. And we can see that there would be an x-intercept when x equals 1. So I've put that as a point of interest. I can also see that x can't be 4. So definitely I can say that when x is 4, I'm going to have x minus 4 being 0. And that's going to make the whole left-hand side undefined. So the left-hand side being all of this. It's all going to be undefined. It's no go zone. Whereas I can say that when x is 1, x minus 1 will be 0. Now, this is like a number line. These are numbers smaller than 1. These are numbers in between 1 and 4. These are numbers bigger than 4. So if you can see that you've got 0 here, then anything smaller than that's going to be a negative number, and anything bigger than that's going to be a positive number. Okay? And if you've got 0 here, anything bigger than that is positive, anything smaller than that is negative. It's quite easy to see now that if I have a negative divided by a negative, I'm going to get a positive. If I have 0 divided by anything at all, I'm going to have 0. if I have a positive divided by a negative, I've got a negative, and a positive divided by a positive will give me a positive. So I can see the sign of this left-hand side here very clearly by just considering where each of these sections would be positive or negative or zero or impossible. And so now I can tell that if I need this whole left-hand side to be not equal to zero but greater than it, then the only section where that happens is here and here. In other words, when x is less than 1 or greater than 4. So I can write that like this, and I'm done.